Hello guys and welcome back to this amazing channel. This is Abhinav. So in this particular video we will discuss about the Codeforces Round 933. Okay. And it is actually a division 3 round that we will discuss in this particular video. So I was able to solve 5 problems of this particular contest. Okay. The problem number F was also not that much difficult. You can see the number of submissions, and even G was not difficult, but the thing was that the remaining time. The reason being, I invested a lot of time in problem number D and E. So actually in problem number D, I first tried it solved using DP, which I was not able to do. Then I tried it using another approach and I was able to do, which was brute force approach. And then other for E also, I was doing a very silly mistake, because of which I wasted around half an hour, right? So because of some silly mistakes, I wasted 1 hour of my contest. Otherwise, I must be able to solve at least one of the last two problems, right? But no worries. In this particular video, we'll discuss about these 5 problems. I will discuss how I have solved it, and also any mistakes if I have done, why I wasted the time, what was my silly mistake. I will also tell that, okay? And I will also try to upload the solution of the remaining problems in next video after the contest if I will get time, right? So let's start with the first problem then. The first problem was really easy one. The problem says that Rudolf has to visit Bernard, and he decided to take the metro to go him, right, to go there. So basically the thing is that they are saying that ticket can be purchased with 2 coins, and some of these 2 coins should not exceed k. That is what they are saying. And then they are saying that Rudolf has some coins in right pocket and some coins in left pocket, right? Now what he can do, he can take 1 coin from the right pocket, one from the left pocket, and if the sum of both the coins is less than equal to k, he can buy a ticket with that. So you have to tell how many such ways are there. So it's a very easy problem. So basically what you have to do is, in this problem number A, there are some left the points in left pocket, there are some coins in the right pocket. For each and every combination, you will take 1 coin from here, 1 coin from here, you will add their values, and if this value is less than equal to k, you will increase your answer. That's all, right? That's all. So if you will see, what I have done here is, I have simply taken value of n, m and k. So n is the number of coins in the left pocket, m is the number of coins in the right pocket. Now I'm taking input of both a and b vector. Now for each and every I comma j, means for every combination I am checking if the sum of value from both the coins, from left pocket and right pocket, if this value is less than equal to k, we will increase the answer. That's all. And then finally we will print the answer, right? So this was a pretty easy problem that we discussed here, okay? Problem number A. If you have any doubt regarding this, you can comment down your doubt, or you can also join our Telegram. We will discuss our doubts there, right? Amazing. Now let's talk about the problem number B. So problem number B was also very interesting problem, but again a greedy problem. So actually people tried to solve it in a different way, but it was a clear greedy problem. Nothing complex, right? The problem was simple, that Rudolf has an array of n integers. Now what Rudolf can do, Rudolf can take a particular index I. He has to decrease the value of I by 2 and their neighbors by 1. Okay. So basically, if it is choosing an index I, so AI will become AI minus 2, and AI minus 1 will become AI minus 1 minus 1, and AI plus 1 minus 1. So for example, if the array is like this, let's take an example. Let's say 1, 3, 5, 2, 2. Okay. And let's say Rudolf opt for index this one, for example. So he has to decrease this number by minus 2. This will become 3. And their neighbors will reduce by 1. Right. And this will be the final array if the operation will be performed on this index. ठीक है, बाकी elements remaining वैसे ही रहेंगे. So Rudolf have to do this thing how many times? Any number of time he can do this particular operation. But the basic final thing that he has to do is, at the last he have to make all the elements of the array equal to 0. So you have to basically tell that for the given array, whether it is possible to convert it to 0 or not, right? So it is not always possible, right? That is what you have to basically tell. So how we can do this particular problem? See guys, it's very simple, it's very straightforward greedy problem. People tried to solve it in a different way, and that is what they were not able to do. So the problem was, see, for the border, for the first element, the only way to reduce it is by doing operations here. See, you can do operations only from index number 2 to index number n minus 1. Basically from here to here. You can do the operation. Right. Now, if you have to make this element 0, how many number you have to subtract here? You have to subtract here with the number 1. Right. So if you have to subtract here with the number 1, that means you have to do one operation here. See what I am saying. When you will do one operation at index number 1, so this index number 1 will be decreased by 2, this will be decreased by 1, and this will be decreased by 1. So remaining array will be 0, 1, 4, 2, 2. And by doing this, we made this to 0. This is done. Now move forward. Now to make this also 0, we have to perform one operation on its next index. So again, -2, -1, -1, and now final will be 0. This was already 0, 2, 1, and 2. Right? Simple. That is what we are doing. Wait. Let me check. Okay. Here it was 5 and 5. That is why it was possible. Otherwise, it was saying wrong. So basically, it was 5. This will remain 5, and now it will remain 4. Right? Now see. Now when we are here, to make this 0, we have to perform 2 operations on its next element. So when it is performing 2 operations, this will reduce by 2, but this will be reduced by 4 because I reduces by 2 times. So when there are 2 operations, it will be reduced by 4, and then I plus 1 again by 2. So this is actually I minus 1, I and I plus 1, and then again it will be 0, 0, 0. And now finally, if remaining all are 0, your answer will be yes. Right? But in some cases it is not possible. Let's take the example of the second case only, which is 2, 4, 4, 5, 1. If you will see this particular test case 0, 1, 2, 3, 4. So for the first, if you have to make it 0, you have to perform 2 times -1. Means on its next index, 2 times operation will be done. So 2 times means this will be decreased by 2. This will be decreased by 4 because the middle decreases by 2 twice, and this decreases by 2. तो अगर हमें इसमें 2 बार डिक्रीज करना है, मतलब हमें इसके अगले वाले आई में, इसको हम आई मान रहे हैं, इस आई में अगर हम 2 बार ऑपरेशन करें तो आई माइनस 1 में भी 2 डिक्रीज हो जाएगा, और आई प्लस 1 में 2 डिक्रीज होगा, और आई में ट्वाइस होता है ना, तो -4 होगा. राइट? 2 बार ऑपरेशन किया हमने, तो इससे क्या हुआ, ये तो 0 हो गया, ये भी 0 हो गया, ये 2 बचा. ठीक है, 0, 0. अब ये 0 हो गए दोनों, यहाँ पे आ जाओ. ये 0 हमने पहले कर लिया, याद है ये भी 0 हो चुका ऑलरेडी, इट इज ऑलरेडी 0. Now for here we have to again perform 2 operations. So if you have to perform 2 operations here, I have to do -2 here, again -4 here and -2 here. This will become what? 0, 1 and -1. And we will check only till here only, till n -2 only. Right? Now you can see for the remaining, they both should be 0, because now after this we cannot perform any operation. We don't have 3 elements left. So if they are not 0, the last 2 elements are not 0 if after performing the remaining operations, that means answer is no. So here you can see it became 0. Here it's not 0. Even it became negative. So even if a number is becoming negative, it's not possible. Answer will be no. So here I will say answer is no, and here answer is yes. Got it? That is what we are doing. So if you want one more example, I will give you one more example. For example, with the next example, which is 0, 1, 3, 3, 1. This is the next example, right? Here if you will see 0, 1, 2, 3, 4, right? This is already 0. No worries. Move forward. This is 1. So this is 1. This is 1, right? So for making it 0, we have to perform one time operation in its next index. So this will be reduced by 2. This is by 1. This is by 1. So now this will also become 0. This will become 1, 2, 1. Now again to make it 0, -1, -2, -1, and they all will become 0. So it's possible. But again, in the next case, if you will take this 560, so 560, and then it is 230, right? If you will see here, so I'm taking multiple cases so that you guys can understand. So here it's 5. So if it's 5, that means you have to do 5 times negative operation, 5 times that operation at, at its next index. So if here 5 times negative will happen, means it will become minus 10, minus 5 and minus 5. Now after this will become 0. That is what we want. It will become minus 4, it will become minus 5, and like this. So because now it became minus 4, you will say answer is no. Because number cannot become negative. Because if it once became negative, we cannot make it positive. So we cannot get all the numbers 0, right? That was a simple approach. So how we can solve it, how I basically solved it. I got compilation error because there was some, I think, compiler issue in today's contest. I submitted and I didn't checked it. So yeah, what I did is I'm first taking n, then the array. Now from 0 to n minus 2, I told you na, like we will just do this thing until here. Until here we can do. For these two from here we cannot do because we don't have 3 indexes. They both should become 0 at the last. It's a important thing, right? So we are doing this. If a number is already 0, simply move forward. If a number became negative, answer is no, we cannot do it. And else, if it's not negative, it's a positive number, let's say. If, let's say, this number is a 2. If this is a 2 number, that means at this triplet, we have to perform operation 2 times. So what will happen? Its next number will be decreased by twice of this, and its next second number will be decreased by this number only. So its I plus 1 is decreased by 2 into error of I, and I plus 2 is decreased by error of I after performing operation that number of time. At the last, if last two indexes are 0, for example, here it became 0, here it was not 0, here it became 0, here it was not 0. So answer is no, answer is yes. If it became 0, it's yes, else it's no, right? So this was again a simple greedy approach. Okay, there was nothing else. That is what we are doing here, right? So if I have solved this problem, if you have any doubt regarding this problem, please do ask that to me in the comment section, or you can also join a Telegram channel to ask your doubt, right? Amazing, great. Let's move forward to the next problem, which is the problem number C, which is Rudolf and ugly string. This problem is actually very interesting, and I have actually used a very great approach for solving this problem. I'm not sure, like I got this problem actually very fast, right, in just 5 minutes, because it was having a very good approach. See, here basically they are saying that there's a string which contains some substring pi and map. So basically they are saying if a string contains a substring pi or a substring map, right? So what you can do, what basically happens is that is called as a ugly string. So a string is said to be ugly if it contains pi and map. For example, if you will see this string, this is ugly. Why? Because it contains a pi as a substring. This is also ugly because it contains a map. This also contains a map and a pi also. Both it contains. So it's obviously ugly. These are not ugly. They don't contain map or pi. We are talking about substring, not subsequence, right? So they are beautiful. So what you have to do is you are given with a string and you have to make that string a beautiful string if it is ugly. And for doing that, you can remove some characters from the string. Now you have to tell how many minimum number of characters you can remove from the string to make it non-ugly. Basically to make it beautiful. So simply what we will do is for every occurrence of map and pi, you will remove it. For example, if a string is, let's say, y, see, for example, this is a string. This string is ugly. Why? Because it contains a pi, a map, and again a pi. So how we can remove these pi, map, and pi from here? Simply, for example, from this pi, remove the I. Okay, from this map, let's say remove M. From this pi, let's say remove P. So now it's not an ugly string. So number of times this pi, map, and pi will occur in a string, that number of operations we have to do. That's a simple logic. But there is one separate logic here. What's the logic? So that is fine, that we will simply count how many times pi and map are occurring, and number of times pi and map are occurring in the string, that will be simply the number of operations we have to do, because for every pi and map we have to at least remove one character. There is one corner case, which is if the string is something like this. Let's say this. Here there is a mappy present. So map and pi both are, we can say, combined. It's a mappy. So in mappy, there's no need to remove character for different separately for map and separately for pi. No, here you can do only for remove p, and both map and pi will be removed. This was a logic, and that is what I've handled. I've basically checked if there's a mappy present, simply remove the p and move forward. One operation. But if map and pi are separately present, so for each map and pi we have to take one operation. That is what I have did. Right. So if you will see the code here, so I'm simply iterating through the string. I'm starting from index number 0 and going up to n minus 1. Now I'm first taking substring from I, means basically substring of size 5 starting from I. If that substring is mappy, that means in just one operation I will remove the p and I can make that mappy to MAIE, such that no map and no pi is present. That will just take one operation and you can skip that part. कि आपने उतने पार्ट को आपने हटा दिया, उससे अगली चीज मैप और पाई हटा दिया. अगर फिर हम क्या देखते हैं, ये तो ठीक है. अब अगर जो अगली सबस्ट्रिंग मैप है या फिर पाई है, लेट्स से आई से लेकर आगे 3 कैरेक्टर्स मैप है या फिर पाई है, अगर इन दोनों में से कोई भी केस है तो हमें ऑब्वियसली उनको हटाने के लिए एक ऑपरेशन करना पड़ेगा. भाई मैप से कुछ भी एम हटा लो, ए हटा लो, पी हटा लो, पाई से कुछ भी हटा लो, एक चीज, और फिर हम आगे 3 स्टेप्स आगे बढ़ सकते हैं. एल्स हम आई प्लस प्लस ही करेंगे. लेट मी गिव यू एग्जाम्पल. राइट, लेट मी गिव यू एग्जाम्पल. फॉर एग्जाम्पल कि आपकी स्ट्रिंग ये है, I'm taking a long string so that I can cover all the test cases, right? Cool. See, we will start from here. First, we are checking for a substring of size 5. तो यहाँ पे 5 की substring, क्या ये मैपी है? No. क्या ये map है? No. So none. So we have to check for 3 things. First, if there's a mappy present, if there's a map present or a pi present. If none of them are present, simply move I plus plus, right? Nothing is present here. Now if you will, sorry, pi present, right? Now if we will come here, from here map is present. That means from this map, so first we will check for mappy. If mappy is not there, now check for map. Map is present, that means we have to do one operation such that this map will get removed, and simply skip this and move forward. Now it came here, you can see we are doing I plus is equal to 3. This we remove one character, it can be any character, it doesn't matter, right? Now from here nothing is present, from here nothing is present, from here pi is present, again one more, from here nothing is present, from here is a mappy present, simply remove this p in just one character, skip your, from here nothing, from here map is present, increase it, and that's all. So for this value will be just 4. Remove a from here, something from here, p from here, something from here, and now it's a beautiful string, right? So that is what we are doing here. This is the basic code that I've did. It was a good problem actually, a really observation based problem. Cool. Let's move forward now. So next, again, this was a really interesting problem. Actually, this problem I tried it solving using DP, which is dynamic programming, but it was actually again a brute force problem only. Not exactly brute force, but a good problem, right? So let's see what we are doing here. So basically here there's a n people that are standing in a circle. For example, here you will see there's a circle of 7 people there. 1, 2, 3, 4, 5, 6, and 7, right? Now there's a ball, and ball is currently present with a person with number x. Let's say here ball is with person 2, or let's say person 4. Here second person, okay, with the person 2 the ball is there, okay. Now what the person 2 can do, person 2 can pass the ball x number of time, or let's say r number of times, either anti-clockwise or clockwise. Okay, for example, let me explain you. For example, 7 people are like this: 1, 2, 3, 4, 5, 6, 7. Okay. And let's say ball is currently with 2. So let's say I'm saying that 2 has to pass the ball 4 times. Right. So if it's 4 time, what can happen is either ball can be gone to 1, 2, 3, either route 6, simply 2 plus 4, 6, or in the backward also it can go. So it can go like this: 1, 2, 3, and 4. So it can go to 5 also. So in clockwise it will go to 6, in the anti-clockwise it will go to 5. There are two possibilities, right? That is basically given. And how we can find? So for example, that let's say that initially ball is present at, let's say 6. Okay. Or let's say first let's for 2. So for 2, let's say ball is present, and if we are saying r is equal to 4, so when it will go clockwise, then it's simply fine that I will add 2 plus 4 is equal to 6. 6 will get the ball in case of clockwise. That is clear. But in case of anti-clockwise, what will happen? In case of anti-clockwise, it will go like this. So you cannot simply do 2 minus 4. So 2 minus 4 will give actually what? Minus 2. But it will go to 5. So in this case, you have to add an extra 7, which is n here. So because there are n people, add an extra 7 here, and this will give you 5. That means at the anti-clockwise, it will go to 5. Right. In this case, value can also become more than n. So let me give you example. For example, okay, this will be better. For example, value ball is with 6, and you have to pass it, let's say 5 number of times. So in this case, back is easy. You can simply do 6 minus 5 and the ball will come here in case of anti-clockwise. But in case of clockwise, what will happen? If you will add 6 plus 5, it will go to 11. But there is no 11th person. So there is no 11th person. That means after 7, it will again start from 1, 2, 3, 4. Simply subtract 7 from 11. So means whenever after adding 5 or subtracting 5, if the value is becoming more than 7 or more than n, subtract n from it. So now means ball will go to 4 after in clockwise manner, right? That is what we have to do. Simple. ठीक है, तो इससे फॉर्मूला क्या बना हमारा? Let me tell you that if let's say currently x is having the ball, if x is having the ball, and if ball is going clockwise, and there are r rotations, so simply in clockwise it will become x plus r, and if this x plus r is greater than n, simply subtract n from it. That's all. And if it is going anti-clockwise, then you have to do x minus r plus n. And if this is becoming again greater than n, subtract n from it. That's the basic approach. We got it, right? Just simply try to understand how you will find that after r rotations clockwise or anti-clockwise, where ball will go. Now let's discuss how we can solve this problem. So basically here what they have given is that you have around, so they actually played m times. They played m times, right? And for each time they know how many number of rotations they did, but they forgot the direction. So they remember the distance for each throw, but they forgot the direction, that in which direction they have thrown the ball, right? So now you have to basically say that, for example, they have played 3 times. They are saying each time they played 2 distance moved. Question mark says that they forget the direction. So when there is this question mark, you have to check for both the directions, for clockwise also, for anti-clockwise also. And 0 says clockwise, 1 says anti-clockwise. That is the problem, right? Counterclockwise or anti-clockwise, right? So basically how we can solve it? See, what we can do here is that initially I will take, let's say initially it's 1, 2, 3, 4, 5, 6, 7. Okay, let's take the 7 wala example, which is I think where it was. Let's take an example where there are 7 balls. Or let me be different one. Okay, let's take this one. There are 5 balls and 3 moves, and what is this one? Okay, x is 1. So initially ball is with the first person. Okay, so let's do this. So 1, 2, 3, 4, 5. Okay, and initially ball is with the first person. This person has the ball, right? And the basic thing is that this is how the moves are there: 4, 0, 4 question mark and 1 question mark. Basically in the first move, 4 time move was there. 0 means in clockwise manner. Then there were 4 times move. We don't know the manner, clockwise or anti-clockwise. So we have to check for both. And then 1 again in any manner. So initially, and then after, finally your answer will be that after doing this particular moves, for considering all the cases, how many different people can get the ball in all the scenarios, right? So initially we will say that our set is, we will take a set. In that set, one will be present. One is present, right? Now what we will do? In this set, currently one is present because one has the ball initially. First move is that one is doing clockwise 4 times. So simply it will become 1 plus 4, which is 5. So this 1 will make it to 5. Simple. So now set will be updated with the value 5. That's all. That's all. This is done. Next is again 4. But now this 4 is question mark, means it can be clockwise also, anti-clockwise also. So if you will do it clockwise, it will become 5 plus 4, 9. And because 9 is greater than 5, we will subtract 5 again. It will become 4. Means if we are doing clockwise manner 4 times, it is coming to 1, 2, 3, 4. Oh, sorry. Yeah, not here. Na? So it now ball is at, the ball was at 5, right? So now from 5, if you will do clockwise manner 4 times, it will go 1, 2, 3, 4. So means now ball is at 4. So one possibility is 4. Means if you are doing clockwise, possibility is 4. And if you are doing anti-clockwise, then possibility is 1. Simple one. Right? How? 1, 2, 3, 4. So it will come to 1. So now you have two possibilities. Now after the second move, we have two possibilities, either 4, either 1. So now set will contain two values, which is either 4 or either 1. Now the last move. Last move is against 2. And now for the last move, we will check in both the possibilities, in 4 also, in 1 also. Now for 4, because for 1 also it's question mark. So again, it can be clockwise also, which is 5. It will remain as it is. It can be anti-clockwise also. For 1 also, it can be clockwise also. And it can be anti-clockwise also. So it's 0 plus 7. It will become 0 plus 5. It will become 5. And finally, the unique persons are 2, 3, and 5. And that will be the answer. So in the final step, when we are at the final case, this final step is the answer, which is 2, 3, and 5. And you can see, yeah, 2, 3, and 5 is the answer for this test case that we are considering, right? So what I actually did in this particular case is, that it was a very complex solution that I have written. I believe that there can be a better solution, but that I did what I thought at the time of contest. I first took the input of all the input, which is VI and CHI. CHI basically is the type of operation, 0, 1 or question mark. VI is the number of rotation, right? Now we are starting from 0 to M. Basically for each move we are checking. Initially ball is at X. So in my set, which is answer, I have inserted X, right? Now what you can do is, if CH is 0, CH 0 means clockwise. So if it's clockwise, simply what we will do, we will check current possible indexes. So currently how many possible cases are there. In that all the cases we will add VI. Because वो सारे बंदे VI आगे भेज सकते हैं बॉल को, और फिर वो जो फाइनल आएगा उसको हम एक नए सेट में डालेंगे, बिकॉज हर बार एक नया सेट बनेगा, प्रीवियस लोग बॉल खेल के नया सेट बनाएंगे, ठीक है, और फिर वो नया सेट को हम अपने आंसर में पुश कर देंगे, जो कि हम अगले टेस्ट के लिए यूज करेंगे. ये चीज रिक्वायर्ड नहीं है. बेसिकली हम ये यहाँ हियर आई वाज चेकिंग दैट इफ दिस इज द लास्ट मूव, यू कैन, आई एम स्टोरिंग दैट आंसर इन अ rest that I'm actually printing at the last, but you can even print this answer at the last. That's not a problem, right? So if it is 0, I'm simply adding VI. If it is 1, I'm subtracting VI and adding plus n to handle that negative case, right? That I'm doing. And if it's a question mark in the else case, I'm doing both. I'm taking plus V means clockwise also, and I'm doing anti-clockwise also. That is what I am doing every time. Set will be updated. In the previous set, all the possible people will perform the next move, and then a new set of possible people will be created. And the final set, after an m minus 1, all the m operations, we will get the answer and we will print it. Right. So this is what I am doing. If you have still any doubt, you can ask that to me in the comment section. You can ask that, or you can also join my Telegram to ask your doubts. Right. Cool, amazing. Now let's move forward to the next case, which is E, the last problem for this particular video. For this, you can see, actually, I was doing a very silly mistake. If you will see my code, here in this code, I was finding a minimum, and for that minimum, I was using int max, and it should be long max. That was the only difference. Because I am taking long, it should be also long max. That was the only mistake I was doing, and because of which I made 3 times wrong summation at test case 7. So if you will see in the final output, I've just replaced it with infinity, which was actually round, long max in my code. That was the only approach, but okay, no worries. It was unrated for me. It was I was not in the division 3, so no matter. There was no rating change for me. Otherwise, I must have got a negative rating today. Okay, cool. So this problem is basically that there are some river. There's a river actually there, where there's a bank on its first column and the last column, and bank has a depth of 0, obviously, right? And this is the middle of river, and each cell has some depth associated with it. Now what you have to do is you have to build some bridges from one end to another end, and that bridges, for example, if bridges from here to here, there will be some support, obviously pillars in the bridge. So obviously the both the ends will have the pillar. They are saying both the ends will have the pillar, both the banks, and we will also make some pillars in the middle, and the distance between two pillars cannot be more than d, right? That is what they are saying. Now you have to tell that you have to basically build k consecutive pillars, basically k pillars in consecutive rows, and you have to tell what is the minimum total cost we can get after constructing k consecutive pillars, and cost of each support, not k consecutive pillars, actually k consecutive bridges, and cost of each support of a bridge is one more than the depth of that particular case. मीन्स अगर यहाँ पे बिल्ड करेंगे तो 1 पड़ेगा, यहाँ पे करेंगे तो 3 पड़ेगा. ठीक है, लेट मी show you how we can solve this problem. See guys, what I will do for this problem, there is a prerequisite, which is you have to solve a problem minimum of k sub array. So let me show you the problem. There is a problem minimum of sub arrays of size k. Minimum. There's a very famous question actually. Let me tell you. Yeah. There, this is a problem. So this is a problem is actually done using DQ. This problem is done using DQ. In this problem, basically what you have to tell is that for every subarray of size k, you have to tell the maximum of that subarray. For example, for this subarray, its maximum is 3, right? For next subarray, its maximum is also 3. For next subarray, its maximum is 4. For next subarray, its maximum is 5. Okay, so that is what the same logic we'll use here. Here we will do it with for minimum, because we want minimum sum. So basically हम कैसे करेंगे इसको? Let me tell you. Let me explain this to you. So we initially have this. Let's talk about one row only. Let's not talk about all the rows. Let's first talk about one row. Let's say the first row. It is 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0. Okay. Now, see, understand very carefully what I am trying to do here. See, to build a bridge here, cost will be 1. That's obviously. And we have to always build a bridge here. That's always. Right. And we have to also build a bridge here always. right? But we will start from the left. So we will always build a bridge here because in both the banks, support will always be there. Not bridge, support actually. So we will have a support here. And because its depth is 0, the cost of the support will be 1. So here I am storing the cost. Now after this क्या बोलते हैं support, let's say my D is 4. So if my D is 4, I can so I can make next support at here. I can skip the previous middle supports. Am I right? Because they are saying that the distance between two supports cannot be more than D. तो अगर D 4 है तो हम इतना डिस्टेंस ले सकते हैं, इसके बाद हमें एक सपोर्ट बनाना पड़ेगा. एम आई राइट? इसके बाद हमें एक सपोर्ट बनाना पड़ेगा. बट वी कैन हैंडल डिस्टेंस ऑफ एटलीस्ट D+1 लेटर. अगर ये 0 है तो हम 4 तक तो ले सकते हैं, 5 तक ले सकते हैं. 5 में आके हमको एक सपोर्ट पक्का बनाना पड़ेगा. वी कैन इवन मेक सपोर्ट्स इन बिटवीन ऑल्सो, बट यहाँ तक तो मतलब इसके बाद नहीं. ऐसा भी नहीं ये सब छोड़ के यहाँ बना लो, दैट इज नॉट पॉसिबल. एटलीस्ट इन बिटवीन दिस रेंज यू हैव टू मेक वन सपोर्ट. Now we will see that if we are making a support at a particular index, what is the minimum cost we can get. For example, अगर हम support यहाँ पे बनाते हैं, कितनी cost लेगी? तो यहाँ पे तो बन ही चुका है, और यहाँ पे बनाने के लिए हमें 2 cost लेगी. We will take 2 more cost if you have to make a bridge here. Why 2 more cost? Why? Because ये 1 है इसकी डेप्थ, तो इसमें 2 more cost लेगी. तो 2 इसकी हो गई, प्लस 1 3 हो गई cost यहाँ तक की. How much cost? It is 3. Right, it was 1 till here, till here it will be 3, right? Now till अगर हम यहाँ भी बनाते हैं तो 2 + 1 3 हो गया, और प्लस ये 1 तो है ही है, तो हो गया 4. इसके लिए 5, इसके लिए 6 और इसके लिए 7. मतलब अगर हम लेट्स से सिर्फ ये यहाँ दोनों जगह सपोर्ट बनाते हैं तब 7 कॉस्ट हो रही है, अगर सिर्फ इन दोनों जगह बनाते तो 6 कॉस्ट हो रही है. अब देखो, अब जब हमें यहाँ पे एक सपोर्ट बनाना है, तो अगर यहाँ पे सपोर्ट है तो इसके डी डिस्टेंस के अंदर एक सपोर्ट तो होना ही चाहिए, एक सपोर्ट तो होना ही चाहिए. अब बात आती है कि वो सपोर्ट कौन सा लें. सो वी विल टेक दैट सपोर्ट, which will be of minimum cost. So in this whole range the minimum cost support will be 3. So you will take this 3 plus this 5 8. Now in this range it will be 4 is the minimum support. So we will take 4 plus this will also be 4. 3 plus 1 4, it will be 8. Right. Now here you will take support for this. This is 3. Minimum here is 5. So again it will be what? 5 plus 3 8. अब इसके लिए आपका आएगा again 8 and इसके लिए आपका 8 आएगा. देखो 6 plus 2 8 and 7 plus 1 भी also 8. So means फाइनल जो मिनिमम कॉस्ट लगेगी इस रो में ब्रिज बनाने के लिए दैट विल बी 8 ऑन. बट फॉर दैट वी नीड अ लॉजिक हाउ वी कैन फाइंड मिनिमम फॉर लास्ट D+1 इंडेक्सेस. हमें लास्ट D+1 इंडेक्सेस मिनिमम चाहिए, बिकॉज उसी को हम ऐड करेंगे हमारे करंट वाले इंडेक्स के साथ में. और ये कैसे निकालेंगे? फॉर दिस विल यूज द लॉजिक ऑफ दैट प्रॉब्लम विच आई टोल्ड यू, दिस वन. इसका जो लॉजिक है ना दैट विल यूज, एंड दिस प्रॉब्लम इज एक्चुअली सॉल्व यूजिंग DQ. So I will tell you how we can solve it using DQ. A very quick approach. You can solve a separate video for that problem, but I will tell you a quick logic, right? For example, if it is like this, so and you have to find minimum. We need minimum. We don't need maximum, right? For example, if we have our D is 3 or our K is 3, means we need minimum of K for each subarray, right? So हम क्या करेंगे? We will take a DQ. We will take a DQ. This is the front of the DQ. This is the back of the DQ. In this DQ, we will insert the indexes of each element, and we will maintain the minimum element at the front. देखो अभी तो हमने पहले 0 को इंसर्ट कर दिया. अब देखो नेक्स्ट इंडेक्स इज 1, बट यू विल सी द वैल्यू एट इंडेक्स नंबर 1 इज लेस देन 2. यहाँ पे जो वैल्यू है जहाँ पे अभी है वो वैल्यू फ्रंट वाली वैल्यू से छोटी है, तो हम इसको हटा देंगे, 1 यहाँ पे आ जाएगा. नाउ फॉर नेक्स्ट मोड. अब मतलब इसका मतलब क्या होगा? यहाँ तक मिनिमम है 1, यहाँ तक मिनिमम था 2. अब फॉर दिस 5 दिस इज 2. अब दिस 5 इज नॉट लेस देन 1 विच इज एट द फ्रंट. Simply insert the index of 5. Now this is 4 which is 3 which is 3. तो यहाँ तक मिनिमम हमारा 1 ही आया था. अब दिस 3 इंडेक्स नंबर 3 वैल्यू 4, दिस वैल्यू 4 इज लेस देन 5, तो हरा दो इसको. देन दिस 3 विल कम हियर. यहाँ भी आ गई 1. अब जब यहाँ पे आएंगे तो ये 2 है, ये भी इसको हटा देगा 4 को. बट हमारे इसके लिए 1 भी हट जाना चाहिए. वाई दिस 1 शुड रिमूव? बिकॉज यहाँ के लिए k से ज़्यादा जा रहा है, तो ये जो इंडेक्स है ये n माइनस के छोटी नहीं होनी चाहिए है, तो उसको भी हटा देंगे. तो I will recommend, I cannot explain this all in this particular video because then this video will become very large. I will recommend you guys to please see the editorial for this particular problem. Actually, in Geeks for Geeks even I have made a video for it. You can check it out, right? That video. And that logic I'm using here of DQ. So what actually I'm doing here is I'm first taking input, right? Now I'm for each row from 1 to n, I'm taking a DQ. I'm doing the same. For first d plus 1, हमें पता है कि जो हमारा करंट डेप्थ है +2 कर रहे हैं. +2 क्यों कर रहे हैं? एक तो उसी मान लो मेरे वाले सेल की डेप्थ 5 है, तो 6 तो लग जाएंगे वहीं पिलर बनाने के लिए. और +1 जो हमारा सबसे बैंक वाला पिलर था, सबसे पहला वाला, तो वो हमने यहाँ पे ले लिया. कितनी कॉस्ट यहाँ लग रही है. बच्चे के लिए हमने क्या किया कि हमने पिछले डी पिलर्स में जो सबसे मिनिमम था उसको हमने यहाँ पे ऐड कर लिया है, और हम लास्ट वाले पिलर को यहाँ देख रहे हैं उसमें प्लस कर रहे हैं. तो बेसिकली फॉर ईच रो वी आर फाइंडिंग व्हाट इज द मिनिमम वैल्यू ऑफ द पिलर्स दैट वी कैन गेट, एंड दिस विल फाइंड फॉर एवरी रो. जैसे हमने इसके लिए आप देखोगे वी फाउंड 8 फॉर दिस. ठीक है, इसके लिए अराउंड आएगी, इसके लिए आएगी आई थिंक अराउंड 4 आई थी इसके लिए, व्हाट आई रिमेंबर. एंड इसके लिए भी अराउंड ऐसे कुछ 8 आई थी आई गेस. और क्योंकि हमें यहाँ पे k की वैल्यू 1 दी हुई थी इन दिस फर्स्ट टेस्ट केस, so we have to simply take 1, so we'll take minimum which is 4. हमें सिर्फ एक ही रो लेनी है ना, तो आंसर 4 था. But when we have to take more than one row, then the answer is very clear. We have the value of this answer, this. Okay, simply find the prefix sum of this, and if you want k consecutive rows, simply find the sum of the sub array of size k, minimum sum of the sub array of size k. दो अप्रोच, तो हमने 0 से लेके k-1 तक के सब अरे देखी, फिर i और j इंक्रीज कर रहे हैं. तो बेसिकली फॉर एग्जांपल फाइनली हमने जो है हर एक रो के लिए वैल्यू निकाल ली. फॉर एग्जांपल a1 a2 a3 a4, we found that value for every row, right? And let's say now our value is k is 3, so for every subarray of size 3 we are finding the summation, and finally we are giving the minimum of that summation, so that I can understand that this problem is really complex. Or maybe I have written a very complex code, maybe someone has written a better code, I'm not sure, but this is what I was able to thought at that time. The mistake I was doing, because of which I made 3 wrong summation, I was taking int max here, it should be long max. That was my mistake. So this was my approach. It is really difficult, I can understand, but I can also say that if you will understand this part, this is nothing, but if you will understand the problem which I told you, which was that IPL problem, if you understand this one, how you are getting the maximum of each subarray of size k, right? Maximum of each subarray of size k, or let's say there was a problem minimum I guess also, or let's say maximum of each subarray of size k. Yeah, this one was there, the same problem they are showing. So if you will solve this problem, you will definitely get this logic. ये logic क्या है? And it's I will bet you guys, this is a very important logic. This is a very important problem. This was asked to me in Zscaler, and in a lot of companies it is being asked. In Amazon it is being asked, right? The बहुत important problem है, please do solve it. And this was the approach. If you understand that, you will definitely understand this. And actually guys, I can understand this was a really difficult approach that I have used, right? So guys, that is our 5 problems that I was able to do. If you have any doubt in this problem, please do ask me. I will also try to solve the other 2 problems and will try to upload the videos. If you have any doubt, do ask that to me in the comment section, or you can also join the Telegram channel to ask your doubt. Please comment helpful if this particular video is helpful for you. Also, please do subscribe to the channel and like the video. Thank you.